Assalamualaikum. My name is MOHD by RUSDI. Today I want to talk about optic lights and wave. Okay, first, optic light. We must know properties of light, light emission color, law of reflection and refraction, light wave, and fiber optic. Okay, nature of light. Light waves are part of a group of electromagnetic wave or radiation that include X-ray, ultraviolet, infrared, and radio wave. Light waves have a certain properties which are common. These are they travel through space at the speed of light, which means 186,000 miles per second. They obey the equation. They can carry energy from one place to another. In free space, all electromagnetic waves have the velocity of light, which is 186,000 miles per second. The electromagnetic spectrum, as we can see the example shown. Okay, light dispersion. Within the light spectrum, there are 6 colors that can be readily identified, like orange, red, yellow, green, blue, and violet, with indigo being difficult to distinguish. Sir Isaac Newton was the first person to explain this band of colors, known as the spectrum, using glass prism. Light dispersion. When light passes from one medium to another is refracted, which means change angle. When white light passes through a prism, it is refracted twice, with red light refracted the least and violet refracted the most. The separation of white light in this manner into the color of the spectrum is called dispersion. Color combination. Object appears color because their surface will absorb some of the frequencies and reflect each other. Red, green, and blue are known as light primary colors, as they cannot be created. But secondary colors can be created by mixing two primary colors. A red filter, for example, will only allow light with the longer wavelength, with the color red to pass through. Reflection. Reflection is the change in direction of light wave when it bounces off a boundary. These are two laws of reflection. The angle of incidence is equal to the angle of reflection. The reflected ray lies in the same plane as the incident ray and the normal at the point of incidence. This law of reflection applies equally to curved and flat surface. There are two types of curved mirror, which mean concave and convex. Concave and convex mirrors. First, concave mirror is a surface that is shaped in towards the middle and away from the observer. A convex surface is a surface where the center is shaped out towards the observer. It is in opposite direction to a concave surface. Okay, point P is known as pole and is the center of curved mirror. Point C is the center of curvature and is the center of the sphere of which the curved mirror is part. Point F is called the principal focus or focal point. In the case of concave mirror, this is the point where rays converge while convex rays diverge. Refraction. A change in direction of light ray occurs when light rays move from one medium to another. For example, from air to water. It is called refraction. The direction in which they are refracted depends upon whether they move into a more dense or less dense medium and respectively slow down or speed up. Observation on light refraction. The ray of light is bent towards the normal when it enters an optically denser medium at angle. The ray of light is bent away from the normal as it enters an optically less dense medium, like example as it moves from glass to air. Should the ray be arranged to enter block along the normal, we must remember that angle of incidence is equal to angle of refraction. Light refracted index. The refracted index n depends on the wavelength of the light. In a vacuum, light waves travel 300,000 km per second, whereas in glass the velocity falls 200,000 km per second. Snell's law. Snell's law states the ratio of the sine of the angle of incidence to the sine of the angle of refraction at the boundary of the two substances is always constant and never can be changed. The constant may be expressed as the refractive index of substance 2 with respect to extent 1, that is 1 and index 2. Lens. There are two types of lens. First is convex lens, known as converging lens, and next is concave lens, known as diverging lens. We can see the example for convex and concave lens. Okay, lens. The distance between the focal point and the optical center is known as the focal length and is given the symbol F. It is on this value that the calculation of power is made. How an image appears when using a lens can be obtained by drawing two of the following ways. A ray parallel to the principal axis, which is refracted through the focal point F. A ray through the optical center O, assuming no deviation caused by lens thickness. A ray through the focal point F, which is refracted parallel to the principal axis. Where the image is positioned and its nature, whether it's real or virtual, can be found by using formula. Okay, wave motion and sound. There are energy can travel by two forms, whether it's by particle or by wave. A wave is disturbance of a medium which transports energy through the medium without permanently transporting matter. In a wave, particles of the medium are temporarily displaced and then return to their original position. The two most common forms of mechanical wave is transverse wave and longitudinal wave. Okay, transverse wave. Particles of the medium are displaced in a direction perpendicular to the direction of energy transport. The particles do not move along with the wave. They simply oscillate up and down about their individual equilibrium position and as the wave passes. Pick a single particle and observe its motion. Okay, for longitudinal wave, particles of medium are displaced in direction parallel to energy transport. The particles do not move down, but they tilt with the wave. They simply oscillated back and forth about their individual equilibrium position. The wave is seen as the motion of the compressed region, which is from left to right. Water wave. Water wave is combination from transverse motion and longitudinal motion. Waves travel through matter. The particles travel in clockwise circles. Observe the particle in the blue color as it indeed travel in clockwise direction. Okay, wave characteristic. There are 4 characteristics of wave that we must know. First is wavelength. What is wavelength? Wavelength is the frequency between two crests. Okay, next is frequency. The number of wave crests that pass upon every second. If one crest goes by you every second, then we say that the frequency is 1 cycle per second, or maybe we can just call it 1 Hz. Amplitude, the head of the wave crest above the undisturbed position. Velocity, the speed and direction that the wave crest itself is moving. Relationship between wavelength, velocity and frequency. These are simple relationship between wavelength, frequency and velocity. If you know any two of them, then you can compute the third using the formula like the example. Okay, interference wave. Interference or superposition occurs at point where two or more waves meet. There are two types of interference wave. First is constructive interference, which means two waves that have different amplitude are in phase. The superposition of two waves produces an increase in disturbance and a wave formed with greater amplitude. Second is destructive interference. Two waves have different amplitude and the second wave is perfectly out of phase with first. When combined, the effect is to reduce the amplitude of the first wave. Standing wave. Standing or stationary wave occur in wire that are tightly stretched between 2 points. Standing wave patterns are characterized by certain fixed points along the medium which undergo no displacement. These points of no displacement are called nodes. Meanwhile, midway between every consecutive nodal point are points which undergo maximum displacement. These points are called antinodes. Standing wave. Okay, sound. Sound is energy and is produced when an object vibrates, causing the surrounding air particle to vibrate also. Sound travels through air or other medium in the form of longitudinal wave. Sound waves are also called acoustic waves, a region of high pressure and low pressure, known respectively as compression and rarefaction. Region where molecules gather closely together is known as compression, and they move apart from the region rarefaction. The sonic range which can be detected by human ear has frequency between 20 and 20,000 Hz approximately. Speed of sound depends on the medium through which it travels. Sound cannot travel to a vacuum. Its speed is greater in solid than in liquid or gas, because vibration is much easier to submit material having closely packed molecules. Sounds. Doppler effect. What is Doppler effect? Doppler effect is the change in frequency which occurs when the source that is emitting the sound wave is moving. Sound wave in front of the object, they become closer together, giving the appearance a smaller wavelength and greater frequency. But when the object is opposite, when the wave is behind the object, giving appearance of larger wavelength and lower frequency. Sound intensity. They are determined by amplitude and sound wave. The higher the amplitude, the higher the sound. Measure in decibel. Ratio of one sound to another. 1 decibel, the smallest change in sound intensity the human ear can detect. There are examples for the you can see. Okay, frequency. The number of vibration complete per second. Unit hertz. The higher the sound, the higher the pitch. Sound propagation, transmission and reception of sound. Source, medium, detector. Range of human can hear 20 to 10,000 Hz. Doppler effects. The apparent rise in pitch or frequency of a sound as its source approaches the hearer, and decrease in pitch and the source moves away. Sound vibrations cause waves which radiate out from their source at speed of sound. Aircraft move less than speed of sound. The sound moves ahead of the aircraft. Aircraft flies at the speed of sound, produce shock waves. Speed of sound. The speed at which the mechanical vibration of sound travel in elastic medium varies with temperature and amplitude. Mach number. The ratio of the speed of the airplane to the speed of sound in the same atmospheric condition. Mach number equal to speed of the aircraft over speed of sound. Resonance. The natural frequency of a given object vibrates naturally or without the external force. Two objects have similar frequency. If one vibrates, the other can move too. Destructive force. Okay, so that's the end of my slide. I hope you enjoy watching my slide, and thank you. Bye bye.